square plus y square equals to 16. What is the surface? Now, listen carefully. First, observe, very, very important observation. This is x-axis, this is y-axis and z-axis. Okay. X square plus y square equals to 16 is a circle in xy plane. But z is not given, z variable is not given. Then what is the meaning? Extend the z variable. Extend the z variable. Right. If we extend the z variable, upward direction and lower direction, then what happens? It represents a cylinder. It represents a cylinder. Now I will write again clear diagram. Now listen carefully. If you understand the diagram, then only you will get the solution. Otherwise, it is very difficult. Okay. Now this is x-axis, y-axis and z-axis. Okay, I will take the circle here. Circle. Now extend the circle. Okay. And also given z equals to 0. Z equals to 0 is nothing but a circle here. And z equals to 5. This is z equals to 5. Surface x square plus y square equals to 16, which represents a cylinder. And z equals to 0, z equals to 5 is nothing but a cylinder. This piece of the cylinder, z equals to 0 is the bottom circle and circular cylinder. So upward surface is z equals to 5. But and also given included in the first octant. Included in the first octant is nothing but the surface between xy plane, yz plane and zx plane. Yesterday we discussed about the first octant. Now this is nothing but 1/4 of the cylinder. Then what is the actual diagram? Now listen carefully. Now this is this one. Okay. Now observe. Between xy plane, yz plane and zx plane, what is the meaning? This is 1/4 of the cylinder. 1/4 of the cylinder. If you understand, then only this is the surface. This is the circular surface. So here, only this surface here given, included in the first octant. Here z equals to 0, here z equals to 5. Now this is the shaded region. I will write with another color, just for understanding. Yellow color. Now this is entirely the curved surface. This is the cylinder. 1/4 of the cylinder. Okay. Now how to solve this problem? So if you understand the diagram, then it is very easy. So if the curved surface is projected on any one of the plane. So here we have two possibilities. One possibility is projection on YZ plane, this one, or projection on XZ plane. Because if you project on XY plane, you cannot find the points on curved surface on XY plane. So that's why we can project on YZ plane or XZ plane. Okay. So if you understand all these points, then we will solve the problem. First, phi. Let phi equals to, what is phi? Surface x square plus y square minus 16. Minus 16. Okay. What is del phi? Del phi already discussed. I dou phi by dou x plus j dou phi by dou y plus k dou phi by dou z. So find the partial derivative with respect to x, y, z. You will get 2xi plus 2yj. N equals to del phi by unit normal. Del phi by mod del phi. Del phi is 2 times of xi plus yj by 2 times of square root of x square plus y square. Now 2 cancel, xi plus yj by root over x square plus y square is 16 is given, x square plus y square is 16, under the root you will get 4 only. So first we will find the unit normal. Okay. After finding the unit normal, now find f dot n. F dot n. Now dot product of f and n. Okay. Yeah, f equals to zi plus xj minus 3y square zk. So dot product with n. First multiply ith coefficients xz, then jth coefficients plus xy. Just observe. Here multiplying with x, here multiplying with y. Okay. Now x is the common term, then no problem. Y plus z. Now this is the second step. First we will find unit normal. Second one is find f dot n. Third step, if S is projection on, so already we discussed either in YZ plane or XZ plane. Now I will take YZ plane. Then what about ds value? Dy dz by modulus of n dot I. Modulus of n dot I. So dy dz by n is already known, dot product with I divided by x by 4. And also one point is missing here. If you dot product with f dot n, so divided by 4 is also there. Okay. Now this is the third point. First we will find the unit normal, then we will find the f dot n, then we will find ds. Now coming to the solution. Now integral f dot n ds over the surface S equals to nothing but double integral of f dot n is known x by 4 into y plus z, and ds equals to dy dz by x by 4. Now limits. So here integrating with respect to y and z only. Here x by 4 cancel. Now what about the y limits and the z limits? Okay. Z limits are given, directly given. Z equals to lower portion. Now observe along z axis. So what is the lower? Z equals to 0. Upper part z equals to 5.
0 to 5.
0 to 5. Very good. Now what about the y limits? Now observe this curve. From this curve, in YZ plane, x coordinate is 0. This term is 0. Now y square equals to 16. Then y equals to plus or minus 4. In first octant, all are positive, so take 4 only. Already we discussed it. If the surface in first octant, initial values are zeros, starting with 0 to 4 only. Up to this clear? Now coming to integration. Very easy. Integration is also very simple. First integrate with respect to z, then integrate with respect to y. Integral y is 0 to 4, z, yz plus z square by 2, limit 0 to 5, dy. Now substitute the limits. Y is 0 to 4, 5y plus 25 by 2 into dy. Now ordinary integration. 5y square by 2 plus 25y by 2, 0 to 4. Now substitute the limits. 5 by 2 into 16 plus 25 by 2 into 4. So this is 8 times 40. This is 2 times 50. Total value is 90. Just I will repeat again. Integral f dot n ds. I will repeat again. First find out the surface. What is the given surface using the given problem? So what is the surface? Surface is x square plus y square equals to 16 is nothing but a cylinder, is nothing but cylinder. In xy plane, it is a circle. In three-dimensional geometry, it represents a cylinder. Z equals to minus infinity to plus infinity. If you extend minus infinity to plus infinity, you will get a big cylinder. But here, Z limits are given. Z equals to 0 to Z equals to 5 only. Z equals to 0 to Z equals to 5 means now upper part of the cylinder. And also, our surface is included in the first octant only. First octant means the surface between xy plane, yz plane, and zx plane. Now this is the diagram. So if you observe the diagram, we can project on yz plane, this plane, or this plane, because we cannot project. Projection is nothing but the shadow. We cannot predict the point, this point, or this point. There is no much difference on xy plane. But if you project on yz and xz plane, you will get the corresponding points. So for this purpose, project on yz plane or xz plane. Now, how to solve the problem? Now, very simple technique. First, what is the given surface? Given surface equals to phi equals to x square plus y square minus 16. Find gradient of phi. Gradient of phi is nothing but the normal to this surface. Normal is nothing but this one. Normal to this surface. Okay. Now unit normal is, after finding the gradient, unit normal is del phi by mod del phi. Now after simplifying xi plus yj by 4. Then second step is find the f dot n, dot product with n. Here x, y, ij coefficient in the similar way, dot product with f. Finally, you will get this one, x by y plus z by 4. Now projection on yz plane or xz plane. If you project on xz plane, you will get the same answer. Don't worry. ds equals to dy dz by modulus of n dot I. N is already known. Dot product with I is x by 4. Here x by 4, here x by 4, both are cancelled. Then find directly. Now how to find the limits of y and z? Here varying variables are y and z. Z limits are directly given, z equals to 0 to 5. And the y limits, for finding the y limits, what is the procedure? X square plus y square equals to 16. In projection in yz plane, x coordinate is 0, there is no x coordinate. Y square equals to 16, y equals to plus or minus 4. Actually, plus or minus 4. Now in first octant, there is no negative terms because all are starting from 0 only. So 0 to 4, y equals to 0 to 4. Now integrate with respect to y. So here integration with respect to y, integral y equals to yz, integral z equals to z square by 2, limit 0 to 5. Now after substituting, just 1 minute. So you will get 5z plus 25 by 2, then integrate with respect to y, y integration y square by 2, 25 by 2 into y. Now substitute the limits, you will get 90. Now coming to the next question. Similar question. Now try it, take it as homework. There is no much difference between previous problem and this problem. This is homework for you. Homework. Just copy this question. Evaluate integral f dot n ds where f equals to yzi plus yzi plus 2y square j plus xz square k, and s is the surface of the cylinder. X square plus y square equals to 9. In previous problem, x square plus y square equals to 16 contained in first octant between z equals to 0 to z equals to 2. Same problem, same procedure. So first to find phi, x square plus y square, which is given. Then find n equals to, just I will give the outline, del phi. Now this is 2xi plus 2yj by 2 times of x square plus y square. That is already discussed. Xi plus yj by 3. Now f dot n is known. Multiplying with ith quotient, multiply the corresponding ith quotient xyz plus 2y cube by 3. Okay. Now S is projection on yz plane. ds equals to dy dz by modulus of n dot I, that is dy dz by same similar procedure x by 3. Okay, fine. Now integrate f dot n ds, double integral of f dot n is xyz plus 2y cube by 3 into dy dz by x by 3. Here by 3 cancel. Okay. In the next step, here integrating with respect to yz only. If there is any x term, now replace with the given curve. What is the given curve? X square plus y square equals to 9. From this one, so x equals to square root of 9 minus y square. So yz into square root of 9 minus y square plus 2 into y cube dy dz. Their limits already simply given 0 to 2. In yz plane, there is no x term, so y square equals to 9, y equals to 3. So 0 to 3. Now first integrate with respect to z, then integrate with respect to x, you will get the solution. Just try it, definitely you will get the solution. Otherwise, ask me directly. Okay, na? Okay? Anybody?
Okay, sir. Okay, sir.
Okay, okay. Now coming to the next model. Now this model is most important model. Now little bit different from the previous model. Listen carefully. This is most important one. Now evaluate integral f dot n ds if f equals to some function is given, then no problem. What is the surface? S is the closed surface. Now underline this point. Closed surface. So previous surface is not closed, but this is closed surface of the region in the first octant, same sector, same first octant by the cylinder. Y square plus z square equals to 9, and the planes. So x is 0, y is 0, z is not. These three things are not required because the last two things are not required because our surface in first octant default these three are implies. So this is also not required because in our surface in first octant x is also 0. Now what is the diagram? Now listen carefully. This is I will take this is y z because y square plus z square equals to 9. It represents a circle in yz plane and extend. Now x is 0 to 2. If this is x axis, x is 0 to I will take. Okay. So bottom part is x equals to 0. So top is x equals to 2. Same part. But in first octant means between xy plane, yz plane, and zx plane. I will rewrite the actual diagram. This is not required, just only. Now this is cylinder. I will take this one. Right. And this one, listen carefully. This is important one, most important one. Now, this is y-axis, this is z-axis, this is x-axis. Now, this plane is x equals to 2. This plane is x equals to 0. Now, curved surface. But this surface is closed. Closed means now consider all the remaining surfaces. So, xz plane is first one is S1. XY plane is a rectangle. XZ plane, in XZ plane, it is a rectangle. In XY plane, it is another rectangle. Bottom is 1/4 of the cylinder, that is S3. Upper part is S4. Now curved surface is S5. So here, totally we have 5 surfaces. We will find the surface integral over S1, over S2, over S3, S4, and S5. Total 5 surfaces. Then finally add all the values. Then only you will get integral f dot nds over the closed surface. Yes, that's why this problem is most important. This problem is most important. Okay. First, one by one, I will take one by one surfaces. First, I will take S1 surface. Go over the surface S1, which is shown in the diagram.